All right, today we're going to do a composition of transformations, which basically, remember, transformations are like the translations, reflections, rotations, and dilations. So composition is going to be several of them together. So technically, the definition is it's a transformation in which a second transformation is performed on the image of the first transformation, and then it could be another one. It could be many of them. We're just going to do two for right now. Remember now, the image, remember first you had the pre-image, and then we made an image when we did either one of these. We either translated and got an image, we reflected a pre-image and got an image, or any of these other two, okay? Now, a special kind of composition is one that's called the glide reflection. And that's a composition of a translation and a reflection in a line parallel to the direction of the translation. We'll do it real simple though. For example, I can slide this over, I can translate this triangle over and then flip it. This would be an example of a glide reflection. And it really doesn't matter what order. I could have flipped it first and then glided it and I would have still come up with the same result. Okay, we're going to do just a few examples and then that's it. We'll practice a lot of examples in class and you can even make up your own. So I think you'll enjoy this. Okay, first example. You're given a triangle, DEF, you have all these points. You want to find the image points after you reflect it over the x-axis and then you dilate it by 1/3. Okay, so here's what you want to do. Don't worry about the graph first. The first thing you want to do is get the ordered pairs written up as they are in a column. Be sure to complete one transformation at a time. Be sure to complete one transformation at a time. So first you want to order the ordered pairs, write them down in order, DEF, okay, list what they are. Then you do the very first transformation, which in this case is reflection. It'll just be whatever order they say. So remember, reflect it, that R stands for R, reflect over the x-axis. So remember the rule for x-axis, the x stays the same and the y is negative. So I made all these points, I put D prime because that's the next one, and I kept the x's the same and I made the opposite for the y's. Then I took it and then it said to do a dilation of 1/3. Then you go one more step, I put D 1/3 to remind me of what I'm doing. And I dilate it, I just cut everything by 1/3. So 3 divided by 3 is 1. -1 divided by 3 is -1/3. I did that throughout all the points. And then I graphed to check. Okay, so here's my blue is what I started with the blue. So I really should have put this more color coordinated. So the blue is first. And then I reflected over the x-axis, which is the purplish color. The light purple, I guess. And then I dilated it 1/3. And so it looks like, to me, when I look at the graph, it looks like that's what I did. I dilated it, I reflected it, and then I shrunk it. So it looks like that's correct. If some point was way off that I graphed, after I graphed these points, I would have known, oh, something's wrong up here. Okay, that's a way to kind of check. Okay, a few more examples. All right, what if you're given the same triangle, and this time you got to find the image points after a translation of this, and then a rotation of 270 degrees counterclockwise. Okay, so let's talk about that. List your points first. Then I'm going to translate. I'm going to slide it, which you could do. I just subtracted 5 from the first one and then added 2. And then I remember that rotating something 270 degrees counterclockwise. Remember, you always start here. If I rotate it counterclockwise, it really is the same thing as if I did it 90 degrees clockwise. I'd land in the same place. Okay, so I'm going to use the directions I know for 90 degrees clockwise, which remember you always, if you have X, Y, and you're rotating it 90 degrees clockwise, you switch the X and Y, and then you go clockwise, so it's -X. So I believe I did that. So I switched them, and then I opposited the Y term, which is what I did here. And then you'll see that I graphed it. This time I color coordinated it. So to check my graph, I graphed the green triangle. And then I slid it down to the left 5 and up 2, so that does look like what's happened. And then I rotated it 90 degrees clockwise, and that looks indeed exactly what happened. Okay, one more example, I believe. Yeah, one more example. Okay, using triangle, a new triangle now. We have the points there. You want to find the coordinates after a glide reflection, which is composed of a translation of that rule and then reflection over the y-axis, okay? So here we go. We have the points listed. I did the rule of the translation, which just means I just moved it down 2. So I did that in the points, and then I reflected over the y-axis, which means the y stays the same, and then the x becomes the opposite. Then I checked it with the graph, and it checks out, because the blue is first, and then I went down 2, and then I reflected it over the y-axis, and that's my glide reflection. Okay, we'll practice a lot of these in class.